Oh, no. All right, we're back. We are GAME3001. That's Game AI in the winter 2020 semester at George Brown. And we're week 3, part 1 of our broadcast. I think it's going to be the only part. We're going to be talking about a little bit of assignment 1 details, as well as we're going to do some steering behavior for seeking. First, let's take a look at assignment 1. If you look on the left, there's assignments. Here's assignment 1. It's called Basic Steering Behavior. It's worth 12.5% of your final grade. It's due week 5. You can work in small groups of up to 2 people to get it done. I've created groups on Blackboard. So if you go to groups, on the left, you can self-enroll in your groups. Please don't enroll with somebody you don't know. Like, don't just see like, hey, there's a group of 1. I can be his partner, right? Yeah, no. Don't do that. Please know who you're dealing with. There's only it can only take groups of 1 or 2. Some people will choose to work on their own, and that means you need to make yourself a group of 1. Okay, but you will not be able to see the assignment or work on the assignment without being a group of at least 1. Okay, so please do that. So your assignment groups are here. So right now, from an assignments perspective, until at this point, I haven't made it so that it's required to be groups. But right now, since I've done this, if I go to edit, I'm going to edit my assignment. So it's not, instead of it being individual, I'm going to edit it eventually and I'm going to make it groups. Okay, so please bear with me while I rejig this thing after this. All right. So that's one. One part is what you're going to see is your basic stuff. You're going to use the template provided in class. I recommend template version 4. Okay? And you're going to start your scene blank, so no objects rendering. That's what the thing I want you to do. You're going to allow the user to select a type of behavior they wish to demonstrate. Okay? And they're going to do this by pressing a number of different buttons. That's worth 5 points. Now, if you use my template, that's already set up. So I'm paying you to use my template. I'm paying you 5 points to use my template because that whole part, pressing the buttons and doing the behaviors, part of it is there almost, right? So, and I'll show you where that is today, right? So some people last year chose to use their own template because they were using, they were making their game for Game Production 2. And they said, well, I'm making my game for Game Production 2. I might as well use my Game Production 2 template, my game, right, to do it, right? And the problem with that is then they're like, well, I need an extension because I have to add some more stuff so I can do your assignment. And the answer is no, right? I can't, how can I do that, right? So don't do that, please. And the other thing is, from a marking perspective, it becomes way easier if you use my code. And I'm looking at the exact same template. I know where to look, and I'm not going to be confused as to what you're doing for most likely. You're going to be doing 4 different steering behaviors: seeking, arrival, obstacle avoidance, and fleeing. Each are worth 5 points, right? However, I have to tell you that obstacle avoidance is the most difficult one to do. It's mostly more involved than the other 2. It should be worth 20 points, right? But I made it worth 5, and they're equally weighted. Why did I do this? Well, some people couldn't do obstacle avoidance last time. They just couldn't get it to work, right? So you are not going to take a big hit if you can't get one steering behavior done, but you got the other 3, all right? And to give you a chance to get full marks, or near full marks, I gave you some bonus opportunities. So if you add appropriate background music, 1 mark, right? If you add some text, right, so that I can see what I need to do, you get 1 mark. That means you have to incorporate TrueType font, right? STL TTF. If you add gamepad support to move around your target, right? 1 mark. Add sound effects for arrival, for entering and leaving the screen, start of the simulation, of some other simple sound effects. I'll give you 1 mark. So if you do those things, you get 4 marks, and even if you didn't do the obstacle avoidance, then you get like 1 mark. You lose 1 mark overall, right? Which is pretty good. So it gives you opportunities so you can make it up. However, this is what really happens, okay? So what really happens with an assignment like this is this. The people who don't need the bonus marks, they're the people who do everything, including the obstacle avoidance, and get the bonus marks, so they get over like 100%. That's what happens for this kind of assignment. And the people who need to do the bonus marks, they do one of them. They do like background music, and that's all they do, right? And they don't do the obstacle avoidance. And the other ones that they do kind of shoddy, right? And then I can't give them full marks, right? So don't wait to start this assignment. This assignment is due week 5. That's like 2 short weeks from now on a Friday. Like tomorrow, 2 weeks from tomorrow, right? You need to get on this like ASAP, guys, with your group, whoever that is, right? Your group member. So this is a pair programming assignment, and I recommend that both people understand how to do things, because as you go, it's not going to get any easier to get to do some of these things, right? So please make sure that you try it on your own. Okay, submission details: remove the garbage files, create a zip archive. Please do not use RAR. I will not accept RAR files for this one, okay? And last assignment for your last lab, some people handed in their lab 1 with no zip file, with nothing, right? Please be careful when you do your submission. You need to submit something. I can't give you marks for nothing. Even if it was like, well, I submitted, I made a mistake, and it was 5 days later, and can you take this? Here's my zip file. 5 days later. No, cannot, right? It's not fair. I want to help, but it's hard for me to do it. Also, include a little text document or instructions in your upload. So, for example, you upload to Blackboard and you say, I'm using something, you did something that I need to know about, right? If there's nothing I need to know about, and it's just like press 0 for idle, 1 for seek, 2 for flee, 3 for arrival, 4, wherever the buttons are here, that's okay. Just tell me that that's the regular buttons are being used, everything works. If something doesn't work, this is a great place to tell me. Couldn't get obstacle avoidance to work. That doesn't work, right? You know, or I did this, you know, I did, something else in seek, right? As an example. Then let me know what you did, and so that I can give you marks appropriately. Make my marking life easier, please. Right? There's like 100 and something of you, and if everyone combines, I'm still going to mark 50 assignments, at least 50 some odd assignments, right? So make sure you make it easy for me to do it. All right, questions around this? Any questions around assignment 1? That's what's due. It's due 2 short weeks from now. Again, 2 weeks from Friday, from tomorrow. All right, you're going to have questions, I guarantee you. There's going to be like, you're going to come to me and say, Tom, I have questions around the assignment. I don't understand how to do something, whatever it's going to be. Please make sure you have come loaded with questions next week during the lab lecture, because then you'll have only 1 week left, right? And we want to make sure you have all your questions answered. Okay, so that's this part. Please download, if you go to your labs, and if you go to last week's lab, week 2, this week I'll put up the video. If you go to week 2, download, if you haven't done this already, SDL template version 4. I'm going to be using this one. I'm also going to be putting up lab 2 inside the lab. That'll be also due next Friday, right? So I'll put it up. Lab 2 will be next Friday. It'll be due, and it'll be a challenge. It'll be worth 1% of your grade, and I'll tell you what the challenge is going to be very shortly. You'll see how challenging it is. It's more challenging by far than the last lab we did. That's why I'm giving you a week to do it. Okay? Are you ready? Let's begin. So let's grab our template. Please follow along, guys, because you want to get the most out of this one. You need to follow along with me. So I'm going to grab template version 4, just like you, from Blackboard. I'm going to grab it from here locally, and I'm going to paste it on my desktop, my messy desktop now. It used to be cleaner, I swear. And then I'm going to extract it so I can see it. So there's my template version 4. So just like you, I've got my template version 4. I'm going to delete my zip file. Let's get rid of that. And then let's rename this template version 4 to something that makes sense. So GAME3001, Winter 2020, and it's lesson 3D. You guys are the last team I'm doing this, working with this week on this one. So that's what I'm making. Okay, so I'm going to open this up and then double click on my solution file to make it run. It's going to run Visual Studio 2019, and it's going to ask me to do some rejigging. So it's going to ask me to do this, the SDK version, the platform toolset. I'm going to press OK. It's going to update me. Yours might do the same thing. unless you're using Visual Studio 2017. Okay. And I'm waiting for my solution to finish. And now when my solution is finished, I can right-click on my solution just to make sure, and I recommend still retargeting your solution. Retarget your solution so you're good to go. There we have it. And now let's run this thing and see what we got. So last time when we ran it, we have a little, our ship. Here's our ship. And we have a little target. If you press the WASD keys, you should be able to move the target around, right? So what I want to do today, first step, is I want to move the ship. Whenever the target is moving, the ship is going to move to seek the target, okay? And some of the things is, I'm going to help you guys with your first part of your assignment part 1, which is seek, okay? At the end of today, you should have some kind of marks if you just followed along for your assignment number 1. That's what I'm trying to do to help you out. Again, I recommend on your own next week, you finish arrival and you finish fleet on your own, all right? So how would I start seek? What would I do? Well, first of all, let's reorganize the project because the project has header files, all these header files and all these source files. And I think it might be best to reorganize in some different filters. So I'm going to right click on my template here. And I'm going to add a new filter. I'm going to call this filter objects. Again, this could be called game objects or whatever. I want to make another filter also for managers. And I want to make one more filter for enums. All my enums are going to be separated. All right, so let's do objects first. So I want to go into my source files, doesn't matter which one. Grab my cloud, island, ocean. I'm just control left clicking, player and ship and target. Get all these things, and then just drag all these into my objects folder. So like this, which is not a folder, it's like a filter. Some people ask, what's the difference between a filter and a folder? It's like a virtual folder here inside Visual Studio. It doesn't really appear at all in the operating system files. All right, next, we want to do the same thing. What was that? What do you mean? I right-clicked on my template, and then I said add new filter. That's how I made all the folders. Those are just filters. They're not really folders. All right, next, I want to grab my header files and do the same thing. So I'm going to cloud, island, ocean, player, ship, and target. And I want to just drag these things, left click and drag into objects. So now those are all together. And let's do the same thing with managers. So let's grab my collision manager, my sound manager, my texture manager, and grab that and put it into managers. Same thing, collision manager, sound manager, text manager.h. Grab those and put it into managers. So I'm just reorganizing my code here for now. For those people watching the video, if you don't have this, just skip ahead. All right, and then what we want to do is enums. There is a set of enums that I put in. If you look at the game.h, gameObject.h, I have two enums that I'm using right now. One which is called gameObjectType. This is in the gameObject.h, and one that's called state. Two things. The state enum needs to be renamed and also taken out. And these two enums have to have their own files. Let's make the files first. So I'm going to right-click on enums and add a new item. Remember that I have to target where the item goes on the bottom. So make sure that you go to, instead of template, it should be in the SRC folder, the source folder. Press select, and that's going to be where the file goes. Make sure they're both header files. I just need header files for these ones, no CPP for enums. And the first one is going to be called gameObjectType.h and add it. Yay, there's gameObjectType. And I want to do one more. I'm going to add them first and then configure them. Next one I want to add in, new item, another header, and this is going to be called steering state. Steering state.h. So I add those two files in there. Yay, steering state. And we can look at the gameObject.h file, right? Here's the gameObject.h file. I'll look at that. And what I can do with this is if I take this GameObject and tear it into, or move it to the right here. So I hover over this little piece right here. I can kind of do a split screen of what I want to add. So my GameObject type, that's this. Let's look at GameObject type. I want to pull this stuff, this enum, I want to cut it, and I want to put it in here. Okay, GameObject type. And then I want to include GameObject type to replace that. Include GameObject type, because now it's outside of my class, right? So that's the first thing I want to do. So GameObject type moved over here. I do like to use this kind of functionality, so I'm just going to copy this in my preprocessor commands. Instead of GameObject, I'm going to call it GameObject type. GameObject, oops, type. That's what I'm going to call it. Just so that way it's named the way I like it. You may not like this way, and you might say that you don't care about that, and you already think that Pragma once is okay, and I'm fine with that. Okay, that's my first enum. That's complete. So why am I separating it? Because maybe I'm going to use GameObject type other places in the future. By the way, I will. But for now, you don't know why. So that's one. I want to just do some preparation. And also, I want to teach you guys how to remove things from one class and put it into another thing. Okay, for state, I want to do the next one, which is the state one. First of all, are you guys all up to date with me on this? Have you done this? Are we good? Can I move on? Okay, I'm going to just close this down. So steering state, that's what I want to call it, but it's called state. It's a good idea to rename it here. So rename into steering state. Okay, it's going to ask me to, for this little dialog box to rename. I'm going to rename it to steering state. There it is, steering state. And I want to pull this steering state now out of here and put it over here. So remember that when a reason why I renamed is because somewhere in here it's using state as my state, idle, seek, and so on, and I want to call it steering state. And then let's just include it so it can still work. Steering state.h. So now it just takes the place of what was there before. All I'm doing is injecting this right here, right? And again, just like last time, what I want to do is I want to use that if not defined sequence, where this one is going to be steering state. That's just my sensibilities, right? I like to make sure it's like that. And then end if. Okay. That takes care of this part. So that's your steering state enum. Steering state enum, what we do is we can check to see what state we're in, if we're idle or if we're seeking, or if we're arriving or avoiding. These are all the states you need for your assignment 1. And it's I've kind of already built it up so you can use them. I'm just going to get rid of this now. Are you with me? Have you done steering state with me now? So the steering state, we did GameObject type, or GameObject type and steering state, those two things we need. In my Solution Explorer now, you should see a structure that looks like this. So I have my managers. These are the managers. If you're watching the video, you can slow it down or pause it. My enums, GameObject type, which looks like this, as well as steering state that looks like this. Okay, those are my managers. And then in my objects, I have all of these, because then all of my game objects are in one place, right? And then my header and source files are just enough to get me going. Okay, that's this. All right, but what I really want to do, this is what I want to do, I want to make my when I run this thing now, and let's test it to see I didn't break anything, because when you make changes like this, you should always rebuild your project to see if it's working. So I rebuild it, and there it is. Okay. One thing I want to do is, as I'm working today, I'd like to put this up on GitHub. So let us go into Open Folder and File Explorer. And what I want to do here is, you see that there is a gitignore file. I'm going to double click on my gitignore file. I'm going to open up in VS Code for a second. one thing about the gitignore file, right now if I put this up to GitHub, it ignores the bin folder. I don't want that. I'm just going to comment that out with a hashtag. So if I go here and comment out the bin folder and also the debug folder, then this way I can add in all those things locally. Okay, so that's one. I also want to get rid of my .git folder altogether, right? So right now I have a .git folder. I'm just going to get rid of it and rejig it, redo it. Right, so here it is. And the way to do that, I'm just going to use my command line for now just to make it work. I'm just going to redo it and put it up on GitHub. So I'm going to do cd space. And one thing you can do in Windows, some people don't know this, but you can just like drag and drop your folder and then just press enter to kind of navigate there. So with cd, where it means change directory to this folder. So you can see that I'm in that folder now. And what I can do is git init, git add dot, git commit -m. You can't see that because of all this stuff. I'm just going to put this up on GitHub so when I'm doing stuff, you can, if you lose me, you can follow along. Git commit -m, initial commit. The standard is initial commit or first commit. Okay, good. So I've kind of created a commit, but now I need to connect it to GitHub. So I'm going to make a new GitHub repo. GitHub.com/George Brown College is where it's going to be. This is the GitHub repo that we're going to make. And I need a new GitHub repo, so let's make it. So it's going to be called GAME3001, Winter 2020, and Lesson 3D. Okay, that's where it's going to be. I'm just going to grab these last two lines of code to connect it. And then my system's set up so it's not going to ask me to log in. It's just going to push it up to the master branch. So if you want to follow along and somehow or another you lose track, please go up on this GitHub repo. And people who are watching who are not part of this class, another class, you can also download this GitHub repo as we're going, and it should work for you. One thing to note is my bin debug files have all my DLLs, and my lib files have all the lib files up here. So now it will work if you just download this and run it. Right? Before it wasn't running because it was missing the bin debug folder. All right, so we've got GitHub going, we've got everything running, and what I want to do, this is my base case, my base level. What I want to do here is when I run this thing now, right, I want to move my target, and I want the ship to seek my target. That's what I want it to do. Okay, so how do I do this, and where do I start? Well, we know that if I look at the PowerPoint, on page 28 of last week's PowerPoint, so that's PowerPoint lesson 2, you can see that I had this interesting steering behavior stuff for seek. This is the seek algorithm from last week, right? I want to do this, right, somewhere in my code, right? So I want to be able to set up something called steering velocity, which is like my target direction, that's what this is, or the desired direction that I want to move in. That's what I want, that's what that is. And by default, remember I talked about this morning in lecture that we're going to use vector subtraction to basically get an arrow that points to from where my ship is to where my target is. That's what we're getting. And then I'm going to normalize that. So I'm going to get a vector length, a unit vector of 1. That's what I'm going to do. So I know the direction that I'm moving in, right? That's what's going to happen. And I'm going to multiply that normalized value by the maximum speed in order for me to move my object. So let's do that part first. So I'm going to do it inside my game.cpp file first, and then we'll move it into ship, okay? And we need to clean up some stuff as we go. So let's go into my game.cpp. I'm going to, in my game.cpp, I'm just going to go down and start cleaning some stuff up. So I want to go into the update function. Let's go there first. So here's my update function. An update function has a bunch of junk. Let's pull this out. My draw function also has, my render function has some junk. Let's pull this out. Right, so again, I'm just going to pull this out of here. So we just don't have any comments anymore. We don't need those ones. But notice what I'm doing is I have my render and my update, and I also have something called create game objects. create game objects. I'm just going to clean this up. I create two objects. My ship, I instantiate a new ship, and I allocate memory on the heap, and then I instantiate a new target. That's what it does right now. So those two things is what it does. And where I really want to do all my work is in my update function. So let's just do it here for now. We'll move it up after this. So what I want to do, following the PowerPoint, is I want to create some kind of object called steering velocity. So I can make it a GLM vec2, and I'll call it steering velocity. And I'll say that the steering velocity is my target position. So m_p target, and then get position, minus my ship's position, m_p ship, and then get position. Oops, get position. All right, so that's what this is. That's my steering velocity. But this is not a normalized value. This is the whole length, the whole magnitude. It's like I got an arrow that's drawn from my ship all the way to my target. It's too big. It's too much. I want to normalize this value. That's the next thing I want to do. And normalization happens here, right? The next step. But how do we normalize? Well, we need a little function for this, which I provided for you in the util library I gave you already. So if you go up to the top, let's include the util library. So I'm including util.h with a capital U. And when I include util.h, right, then I can do something like this. Well, my steering velocity then, my real steering velocity, right, well, that's equal to util : normalize steering velocity. Okay, so that takes my steering velocity, it passes it through this function, normalize. Let's go to that function. And what normalize does is it uses inverse square root. That's what we actually talked about in class today, the inverse square root problem that was like magic that ran in Quake 3, right? And without an inverse square root, we did estimation to get the inverse square root. But here we're using the actual inverse square root. And it's going to return the normalized value between 0 and 1 as an example, right? One length of 1 for my unit, for my vector, or unit vector. That's what it's going to return, okay? So, so now my steering velocity will be a unit vector of a magnitude of 1, right, with x and y values that make sense for that. Okay, cool. So now that I've got my steering velocity, I want to set my velocity from my ship to this new steering velocity. So let's do that. So I'll say that m_p ship, and I'll say set velocity to my new steering velocity, whatever that is. Okay, so that is going to set some motion in play, some motion of my ship, but now it's going to be very slow. If I was to run this thing right now, it's going to be like super slow if it was to work at all. And you can see that, well, nothing's working, and that means that we have to fix my ship up. Let's do that first. So I'm going to go back to my solution, go to my ship, so objects, and I want to go to my ship.cpp here. Here's my ship.cpp. And I want to go and do some cleaning up. Like when you see comments like this, just clean them up for now, because we're just going to clean. So there's my update. My update doesn't do anything right now, so let's just clean this up. Okay? Turn right and turn left. Let's just clean this up. So clean up, turn right, clean up, turn left. Let's clean those functions up. And let's clean up move. Let's get rid of everything in move except for the last two lines. All right, so last two lines should be these two lines. And that's my ship's move function. Okay, so move. I got move, turn left, turn right. Turn left and turn right now are empty. Check bounds. Let's get rid of these comments only, but keep the rest of the code. Let's see what that does. And then if I scroll down, reset. Let's get rid of reset. So I don't care about reset right now. And completely destroy seek, because that we're going to redo our seek function on our own, right? Seek actually is not doing what I asked you guys to do this semester. It's doing something else. Okay, so seek, reset. I've cleaned up my ship, but in my update function, let's call the move function. So I'll call the move from my update, right, in my ship class. And what the move function does, if I look at move, Move simply just takes my current position and adds my velocity vector. That's all it does. However, we need to multiply this by max, from this, we need to multiply it by max speed. So let's do that for now. So multiply by m underscore max speed. That's a thing in the ship. And then when I run this thing now, it should move, should seek towards your target. So anytime I move my target, it should do the seeking behavior. Okay? Are you with me? All right? Notice that wherever I move my ship, it seeks now to wherever I am. It just goes to where it is, right? However, there's some problems. One, I'm not using the seek method of the ship. I'm actually did a little test outside of it, inside my game.cpp, and it doesn't do what it's supposed to do. I'm supposed to press 1, and then it's supposed to turn seek on. And when it's found its target, it's supposed to go back to idle. That's what it's supposed to do, and it hasn't done that here. Okay? So how do I do this? How do I make it so that I can pull some of the stuff I've done in my game.cpp, which is here in my update? How do I pull this into my ship? Well, let's just cut and paste. So I'll take this part here out of my update, cut it. I go into my ship.cpp, and I'm going to scroll down to where it says seek here, and I'm going to paste. Cool. But now there's some stuff that we see here. One thing is my ship's position. We just have to say get position. That's all we have to do here. Target. I have no idea. We can fix this one. But I have no idea how to get the target in here right now because, well, I do have an idea. But because the target, there is no way of getting the target. Because the ship, if you look at the solution, if you look at your ship.h, ship.h shows us that we have a target vector. This is the target vector, right? And this is the target's direction. That's what that is. That's a GLM vector. That's not the target position. Actually, this is the target position. This is the target position. So let's rename this thing to target position. So rename m underscore target position. Yes. That's what this thing is, right? However, there's no way to get to it because it's private. So we need to create some getters and setters. And some people don't like getters and setters. They're like, it's a waste of time. I can just directly access stuff. I make it all public. Guys, don't make your private instance variables public just to solve a problem, right? Remember, we use proper object-oriented programming practice here. In another coding house, they may tell you, yeah, everything is public, and you're good to go. Who cares? Here, we don't do that. We do it like this. Private instance members, public properties, or getters and setters. That's what we do, all right? That's our coding practice. So here in our getters and setters, we need to have a get target position and set target position. Let's do that. So we're going to say a get target position. It's going to return a GLM vec2 object, get target position. And we're also going to set target position. That's going to be void, set target position. And we're going to pass in a new GLM vec2 new position. Okay, so that's the declaration. Let's define them. So I'm going to just click on this thing. I'm going to get this little wrench. I'm not using ReSharper C++ today. And then just define it. Locally here, when it pulls up this little inner window, I'm just going to return m underscore target position. So I'm defining what this thing is. So get target position does this. And then the same thing goes for set target position. I'm going to click this little wrench, create definition, and then set target position as m underscore target position is equal to new position. Again, I'm doing this by value. That's okay, they're so small. All right, so that's what this does. I set up my getters and setters. And now that I set up my getters and setters, I'm confident that I can set them outside of this class. Back to my ship.cpp. In here, it should be get target position is what this should be. Get target position. I'm going to use even my getters and setters inside of my class. One of the reasons why we use getters and setters is because they're functions. I can do multiple things while I'm setting a value, right? If I don't use getters and setters and I set a value, I've talked about this before, then all I can do is set that value up. I can't do anything else, right? But with functions, I can say I can set the value, I can log that value has been gotten, it's been requested. I can log that I've set a new value. I can update the UI. I can do other things in that function. And that's why it's also a really good thing. When you just set a value from a data member directly, you can't do anything. You have no access to do anything else. Okay, so that's this. That's seeking. That's cool, but it doesn't really do this seek behavior. I never call seek in my ship, right? My ship right now, if I go back up to my update, it does move. And anyway, I want to use this, which is my check state. That's what I really want to do. When I press the 1 button, it changes state from idle to seek. And by the way, idle, we don't want to move during idle. We want to not move. When I go from idle to seek, I seek and then I move. That's what I want to do, right? And if I do that, if I can change this update function from move to check state. Check state. And on that, check state, not a great name. What I really want to do is check steering state, because that makes more sense. Check steering state. So I can do that. I can right click and rename that so it makes more sense. So rename. I'll change this to m_check steering state and press enter. And now it's renamed. It's renamed nicely. And I did the rename normally because if I this way it propagates through the entire code. Again, you can see that now it's called check steering state. One thing I also want to do in my my ship is I also in here I want to seek, I want to move, and I want to also do check bounce. m_check bounce. Okay. So those 3 things. So check steering state is going to be triggered every time I update, but I'm not going to move at all. It's going to remain idle until I press the 1 button. Okay, let's try this out and see if it works. So it's building. If I press the 1 button now, it's going to move slowly towards my ship. If I move it away, it's going to keep going to where it was. It's going to go towards that location, and it's going to keep going forever. Why is that? What was that? There's no bounce. Well, no, it's not that, but why does it keep going? I mean, it was going before, and then it stopped, and now it's not stopping anymore. That's a bad thing. Is there a reason why it's happening? So again, I'm seeking, and then I'm moving, right? So let's take a look at seeking and moving. So seeking says, here's my steering velocity, my get target position, and my get position. I get the difference here. I normalize them. My steering velocity becomes 1, right, as an example. And then I set my velocity to this, to whatever that steering velocity is, a unit vector of 1. And then in my move function, I take my position, I get my velocity, and then I multiply by max speed, and then I get my new position. So that's going to happen every frame. So every frame, every frame, every frame. And then, well, there's nothing to check that I arrived, right? It's going to keep going. I know the direction I'm going in, but what am I missing? How do I know that I've arrived, right? I know my unit vector. I'm going to go in that direction, but I'm going to keep going forever. Why is that? I don't know if I don't have no idea if I've ever gotten that, right? So how do I fix that problem? It was okay when I put it in my game.cpp. So in here, when I had it, I had an update, and I would just update this every frame. And what happened was when I called the, what I'm doing now is when I call the 1 button, right? Then what's happening is my state is being set right here, right? So I set my state to seek. What else do I have to do? Well, let's take a look at the code, right? So my code says set the target position, normalize, multiply by max speed, and I haven't done this part yet, but I need to do something here, maybe. maybe what I want to do is set the maximum, my velocity. My velocity is being set already, right? My velocity is being set in my ship. My velocity gets set in my seek, right? Here's my velocity. Whatever my steering velocity is, which is 1, right? It's going to keep going forever, and it won't get there until, right, my target is where it's at. That's the target, right? So maybe, can I check to see if it's near the target? Right? Well, not the distance. I want to check to see if I want to check arrival. This is a little bit different than what I did earlier. If my ship gets close to my target, right, whatever that target was, right? My target position, right? Because this get target position, I know it already. And my steering velocity, well, my problem is this steering velocity is only going to happen once, right? But my target position, I need to set my target position to something. I never did that. That's why it's going forever. So inside of my game.cpp, inside here, I got to set my target position. I'm going to say m_p ship. And I'm going to set target position to m_p target, and then get position. I need to do this. If I don't do this, then I never tell my ship where the target is. So let's try it now. So again, I'm seeking towards that position. I press 1. I move towards that position, and it should stop. Right? And if I press 1 again, it's going to keep going in that position. If I press 1 in flight, it's going to go towards that position. And keep pressing 1 as I'm moving, and you can see that wherever I'm moving, then I'm good to go. So question for you guys, right? When I do all this, I mean, is this okay? This is C, okay? However, it doesn't look great. It doesn't look great. And your lab 1, here's your lab 2 now. You've done lab 1, lab 2 is like this. I want you to go where you're looking. Wherever the ship is looking, I want you to make the ship turn, right? And I want you to go in the direction that the ship is looking. Because right now, I mean, if I press the button, if I move my target over here, and I press 1, it's just going to move in that direction. And if I press the target back here, it's going to go backwards, right? Go backwards. That doesn't make any sense. The ship shouldn't be able to go backwards. It should only go around, it should follow along the path of where this thing is. It should turn at a turn rate, right? So I want you to, kind of, look where you're going. And if you actually look that up online, so look where you are going, behavior. If I look that up, you might see, sorry, I'm getting some other things. Steering behavior. So I want to look where you're going, steering behavior. That's what I want. And you might see some images of look where you're going, right? That's what I really want to do. I want to look to see where I'm going as opposed to just randomly move, on the side or whatever. So there's some things we can do to make this happen. One thing we can do is we can add, we're going to add thrust to our ship to make it go in the right direction. So right now, what's happening is when we seek, we just, move the ship like an object to the right or left or whatever. We're just changing positions. But we're not moving in the direction we're looking, right? In fact, we're ignoring where we're looking completely, right? So is there a way, and this is your challenge for assignment for lab 2, can you move your ship where you're looking, not just seek, right? And that means it makes sense because if you run this code, what it should do is this, right? If I'm moving forward and turning, I should move in this direction that I'm looking, and as I turn, I should turn at my turn rate to get to my target. That's what I do. I should kind of do a nice arc to get there, right? Based on my turn rate. That's what I should be doing. Well, my challenge is, how do we do it? Well, this is where the highfalutin math comes in, right? The stuff that game programmers are like, oh, I got to use math. Yeah, you do. So I'm going to start you off, and I want to set up some tools for you to make it easier. Okay, here are the tools that I want to make it easier for you. 1, can we not turn the ship? Let's move the ship with my arrow keys. I want to move the ship with my arrow keys. When I press the left and right arrow, I'm going to rotate the ship left and right. at a specific turn rate. That's what I'm going to do, right? When I press the up arrow, it's going to move in the direction that it's looking. Let's do that first for my ship. So it'll give you a hint of how you can finish this lap, okay? First, let's do it physically with our hands. If we can do it physically with our hands, we can program the AI to do it, right? To move left or right, okay? Okay, let's do this. So, well, all right, so I want my ship. Here's my ship. I want it to move left and right. I have a move left and or turn left and turn right functions. This is good. But I have no notion of direction. Well, or do I? Right? So I have some, let's reorganize some of this private stuff. So one is I have some steering behavior. Wow, I'm terrible today. Functions. There we go. So I'll put that, this one, check steering behavior, change steering states. I'll also put in seek up there. That's up there. Okay, so that's steering behavior stuff. Check bounds and reset. I'm not really using reset, but that is definitely movement. So I'll say ship movement stuff. That's what that is. Max speed would also be ship movement stuff, right? I have a current direction and I have a turn speed, right? That could be also movement, turn speed. And I have a steer force. I'm probably going to get rid of this for now. Let's not do steer force for now. And current direction is a double. I'm not going to use my current direction as a double. In the previous class, they had a great idea to make this heading. So let's rename this. Rename this to M current heading. Right, I think it's a better name. My current heading. And let's make this a float instead of a double. Current heading. Let's fix this inside of my ship.cpp. I'm going to get some errors up here. Because one thing I got rid of was steering force. And what it's saying is that the current heading is 0. Let's make my turn speed. I don't like that word turn speed. Let's call this turn rate. Rename. So M underscore turn rate, right? My turn rate is going to be like 5. This will be like, 5 pixels. 5 degrees per frame. That's what it's going to turn. That's my maximum turn rate is 5 degrees per frame. Current heading is my angle, right? My current angle of my facing angle. Current facing angle, right? So right now it's facing 0, and this is my max speed. So what do I mean by this stuff? So what I want to do when I run this thing is when this thing is running, then it should move. If I seek to the target, it shouldn't seek backwards this way. It should say, okay, I want to move forward, and then I want to turn. I want to move forward, and I want to turn. I want to move forward, and I want to turn. I'm going to keep turning, and moving forward until it has a nice arc that goes from here all the way this way. Okay? If my object was down here, it would just go this way, it would come down this way, right? If my object is over here, it would turn this way and kind of go down that way, right? So it's going to turn and go in the direction that it's looking, okay? Only in the direction that it's looking. And right now, what's happening is my current heading, sorry, one more time, when I run this thing, my current heading is 0. Let's assume that anything to the right or east, if I'm looking east, that's 0, 0. If I'm looking up, right, that's negative 90. Let's just say, right? If I'm looking to the right, like down, that's positive 90. Let's just say, okay? So that means that when I start off, if my current heading is 0, 0, I pass my current heading not just to everything else, but also to my draw function. My draw function receives an angle that's a current heading of 0, 0. A really easy way to test this is if I go to my turn right and turn left. Let's turn right. So I'm going to say that M underscore current heading, and I'm gonna add plus equals to, right, m underscore turn rate. And when I turn left, right, I'm going to subtract turn rate. Now this right now will only rotate the texture. So my texture, I can rotate my texture, but it's not going to actually physically rotate my direction. It's just going to rotate the way I look. I'm not actually rotating. It's just going to redraw myself in a different orientation. Okay. So when I do this, let's test to see if this works. So for now, so if I rotate right and left, I press the left arrow, you can see that I'm rotating left. Right arrow rotates right. But this is not really rotating, it's just rotating my texture. I'm transforming my texture, that's all I'm doing. So that's what these two things do. Okay. I also need this move function to work in the direction, I'm going to move in the direction that I'm going. I need not only my current heading, but I need a direction vector. I need a current direction, some direction that I'm looking at. So I have my heading, which is an angle, but I need my current direction, which is a vector, right? Or else I don't know what I'm doing. How do I move in a direction, right? So I'm going to go back to my ship.cpp, ship.h, and then let's make a current direction. So again, it's going to be a GLM vec2 object. We're going to call this m underscore current direction. You might disagree with this. Some people say I can do it in one, right? Maybe. I'm going to make it, so I broke it up into two different things here. Here's my current direction. And what I want to do is I want to initialize my current direction so that it's a unit vector by default. What would be my current direction if I'm facing right? What would be the unit vector if I'm facing right? Can you guys figure that out?
1, 0.
1 on the x, 0 on the y. My total unit length is 1. Right? So my initial direction, my current direction should be 1, 0. Let's initialize that inside of my constructor. So my constructor, I can say that, well, m underscore current direction, right, is equal to a new GLM vec2 object with a unit vector length of 1. So this is facing right. That's what this is. So my current direction is a vector with a unit length of 1, facing right. Okay, cool. Cool. What I want to do is I want to calculate the new direction when I'm turning. So when I turn my ship, I'm not just rotating my texture, I'm also changing the unit vector. Because right now it's over here, to the right, right? And what I want to do is when I turn left, I want to change my unit vector, so it's still 1, but it rotates based on where I'm going. Okay? So we need some math for this, and I'll give you the math. So when I turn left or turn right, I need to calculate new x's and y's. So float x. And whenever I calculate the x coordinate, I want to take my current velocity. My velocity right now is 1, right? And I want to multiply my velocity. So normally it looks like this. My velocity, I'm just going to type it in like I'm writing it. My velocity multiplied by cos of theta. That's what I do. That's my velocity cos theta. And that gives me my x component. Okay, and my cos of theta would be my current heading. So if I rewrite this thing, it would look like this. My velocity is 1. I don't care about that. But I do need cosine, right, of my current heading right, multiplied by util deg to rad. I need to convert it to radians. So this gives me my new x component. All right, and then for my y component, I need to convert this into sine. So instead of cosine, it's sine. So cosine is related to x, and sine is related to y. if you're taking physics with me in September, we're going to go extensively into how to break things down into component vectors and components. We're going to break compile or decouple, decompose, if you will, the vector into different components, right? And we need the same thing on here. Well, if we're doing it twice, that means there's an opportunity somewhere, so we can, instead of duplicating, we can maybe do something different later. All right, so this is good. So now that I've calculated my x and y, I need to calculate my current direction. I need to change my current direction to that. So I can say that I want to set my current direction. Okay, well, I can say that m underscore current direction, which is different than heading, right, is equal to a new GLM vec2 object where I have x passed in there and y passed in there. And I can do the same thing for this. Now that I have this turn left and turn right, you can see that I can probably have another function, a little utility function, that's like change direction. And that does these things. And I can pass it in. It's the exact same stuff. I'm not changing this stuff. I'm not modifying this. So it makes sense to have a little utility function. Let me just write that. So ship.h. I'm going to have a little private utility function that's called change direction. So it's going to be void m underscore change direction. Again, a little bit of refactoring. And then inside my change direction function, I want to grab that code that I just did. So go back to my ship.cpp. And I want to grab this part, cut it, and go to my change direction function. I'm just going to hop there. So m underscore change direction, and put that in there. So I'm going to get my x and y coordinates from my current heading, and then do this, because that's always going to happen. And let's hop back to turn left, turn right. And now instead of doing that, I can just change direction. So m underscore change direction, which will do the exact same code twice. Now I'm not really saving a lot because there's only a few lines of code, but it looks a little bit nicer. Are we good? I don't want to duplicate. I want to reuse, right? As much as possible. All right, does this work? Right? How do I know it works? Well, remember that my move will only work, will only push forward if I'm going to press the up button to move forward. Okay, so let's code that in on the game.cpp. So I did this. I did left and right. So I'm in my handle events function. Let's go to my handle events function for a second. Handle events listens for keyboard input, right? And on the bottom right now, I'm listening for WASD. Here's WASD, and then 0, 1, 2, 3, 4. This is for your assignment. And then down in here, I have left, right, and left. Let's make another one. So case SDLK up, up. And what I want to do here is I want to move the ship, m underscore p ship, and then move. Okay? So this will move the ship. Also, just to be fair, usually on the key up, I stop moving and stop doing all those things. I'm just going to put these back and then just move these out for now. Maybe I'll do something with this stuff later on. Maybe. Okay, so let's put it down here. So really I have, in my handle events, I have right, left, and up. Up should be able to move in the direction that I'm facing. Let's see if that works. All right, so if I move forward, I press the button up. I got nothing. Left and right does this, but up, but doesn't move at all. Why is that? I got a velocity of 0 right now, right? If I press the 1 button, you can see that it's going to seek. Doesn't matter what my my state's going to be. It's going to just seek there, right? Because that's what I did with 1. But the move up button does absolutely 0. It doesn't do anything right now. Why is that? So what does move do? Right? Well, seek does something different, right? So if I go to ship.cpp, move does this, takes the position, takes the velocity, and multiplies by max speed, right? And it should move forward. It should call this function. So this should totally work. So when I'm pressing the up button, this should go here. Let's see if it's actually getting here and see what we're getting. So I'll say standard, C out, and then moving forward. Okay, let's see if it even gets here. So I'll run it. And I want to press the up button. It says moving forward. I'm getting there. Look. So it's actually getting to that function. So that's okay, but I'm not seeing any movement at all, right? All right. So so set position is the new position. Get position is this. Get velocity. All right. What is my velocity? What did I do with my heading? Did I do anything with it? I mean, I got my new direction, because change direction, that's way up here, right? So if I go to change direction, which is, where is that change direction function? Here it is. Change direction is down here. And let's just for the sake of simplicity, let's just, well, I can leave it there. So yeah, I got my new direction, right? That's my new direction. And that's going to be my new direction vector. My new direction vector is going to be my new velocity. My velocity right now, right, if you think about this, my velocity right now is 0, 0. My direction is going to be where when I'm looking, right? So I need to change my velocity to my direction. Whatever my direction is where my velocity is going to go, right? So what I could do is, when I change my direction, I could set my velocity as I move forward. So I can set my velocity to some thing. But the problem that I have here is I have no way of getting out the current direction. I don't want to do this all the time. I only want to do when I press the button, which means that I need another getter and setter. So again, I want to say GLM effect2 get direction. I'll say get current direction. Get current direction. And then here I'll do a void set current direction. I don't need to do this, but I'm going to just set it up. New direction. Okay. So get current direction, set current direction. Let's just make sure we set these up. So get current direction returns m underscore current direction. All right, that's what this does. And set current direction, this is maybe more important, which is m underscore current direction is equal to new direction. All right, so that's that one. Okay, so target position, set direction, current direction. I figured this out, right? So I definitely have those. So again, going back to my CPP, when I press up, I want to do something. I want to set my velocity to my current direction, whatever that is. Okay? So again, I want to say that's m underscore p ship, right? And I want to say set velocity. And then my velocity is going to be set to my current direction. So get m underscore p ship, and then get current direction. So it calculates direction, and then I'm going to move there, based on my maximum speed. However, I've just got to point this out here to you guys, right? Move is only going to work as long as I press my button. Okay, when I stop pressing my button, move won't be triggering anymore, right? It's only going to function when I press my button. All right, so let's try this out and see if that works. So again, I want to rotate my ship, and then I press the up button, and you can see that it's moving in the direction that I'm telling it to, right? So as I'm moving forward, That's my velocity. And it's multiplying by my max speed. But max speed is pretty slow, and it'd be really nice if I could set my max speed outside. That means another getter setter. So let's do that. So I'll say get max speed. Max speed is a floating point number, so float get max speed. And then I want to void set max speed, which is a float, new speed. Okay. And then let's do that setup again. So again, I'm going to go in here and say return m underscore max speed. And then I also want to do this one. So I'm going to say that m underscore max speed, right, is equal to new speed. Okay. So that's going to be able to move my ship around in the direction I want and set the speed to whatever I want it to be set at, okay? Outside of my function. Because by default now, if you look at my ship.cpp, what is my max speed? It's in the constructor function. My max speed is 1. That might be too slow. So by default, let's set my max speed to 5. So it's going to be 5 and 5. And if I do it now, it might be, maybe 5 is too much, all right? But let's try this out. So again, here's my target training. If I press 1, it's going to move here. If I press 1, right, it's going to move. It's going to seek to where I was. It's going to seek to where I was. It's also going to do this. I got to fix this problem. This shaking problem means it's trying to keep going like this forever. It's never arrived, and that's a problem. And also you can see that I'm still hitting this move function. What about my ship? Can I turn it? I can. And then I can move my ship, but what's happening is it's not letting me move because I'm in seek still. It's still seeking to the target, right? And so I got to stop seeking. Let's rerun this thing. How about if I move by myself without seeking? So I move. You can see that I can move forward, right, in the direction that I want. So move forward. So if I was really seeking the ship, I would do something like this. I would say, I would turn, move, turn, move, turn, move, turn, move. And in every round, I would turn based on the degrees that I'm going until I got to my ship. That's what I would do. That's how I would run, okay? And then I would kind of seek to my ship, okay? So that's what I want to do, but we've only got, right now, the regular seek happening. So my problem that I have right now is I got to fix seek, right? Because right now when I seek, so this is in the ship.cpp, so I seek, right? Here's my seek. Seeking keeps going. It's going to keep seeking forever. And I'm never going to go back. I can never get to this idle state. I'm always going to be in seek state once I press it. I want to go back to idle state when I've arrived. So I need to check for arrival. It's not arrival, the arrival algorithm. I want to check to see if I've arrived. So let's make a new function. Check arrival. So again, steering behavior, void m underscore check arrival, right? You can also rename this check for arrival or something like that. I'm going to set this up. And let's go to definition. And then inside here, when I check for arrival, I'm going to say that, okay, well, what if my position is in the target location? So if, right, m underscore, get position. If get position, my current position, okay, now here's a question. If it's equal to my target position, right? So target position, get target position, right? Then I want to change my state. So I want to change steering state. M underscore change. I want to change steering state. Here it is. I want to change my steering state or set steering state. M underscore set. Is there something like that? Set steering state. Well, that's bad. It's called set state. That's not good. Set state is just not good for that, right? Maybe we can change the name of that thing because set state makes no sense. Set state is a game object superclass thing. So set type makes sense. game object type. But set state, that should say set steering state. Let's rename that. Rename. So we'll say set steering state. There it is. So set steering state. I want to do the same thing down here now. When I arrive, I want to set my steering state. So set steering state to idle. That's what I want to set. I want to set it back to. But question for you guys: is this ever going to trigger? Reasonably, am I ever going to be exactly equal to my location? Remember how steering works? Regular steering. I have my target, I have my motion, my ship, and it's going to go like this. It's going to be approaching target. And because I'm moving at 5 pixels per frame, I could go by the target and go back, and by the target and go back, and by the target and go back. It's going to keep doing this over and over again. So I need a threshold, some kind of offset to say if I'm within a certain amount, then I go idle. Because watch, if I try this here, check arrival, and I'm going to check arrival here. So check bounds, and then m underscore check arrival, right? I'm checking arrival, see if I've arrived. But will it ever get there is my question, right? So let's try this out. So 1, and no. See how it's still vibrating? Because it's not quite there. Didn't quite make it. It's just outside of that area. So I want to kind of check within a threshold. So going back to check arrival, I want to say that, okay, if my current position is within, right? If these two things, if my position minus this position, if this thing, right, is close to, right? If the distance between these two things, that's what I'm saying, if it's close to, like, I don't know, 2 or 3 pixels, I'm okay. So I can use another utility function for this. I can say that util distance, and I want to use my position and my target position as parameters. If my util distance is less than or equal to, let's say, 2 pixels, right, then I will set my steering state to idle. I'm not sure if 2 is the right number. It might be 3 or 4, right? Let's try this out and see if that works. So again, I press 1, and then it stops. And then if I move my guy again, I press 1, it should stop. 1, it should stop. And how about in the corner? 1, and we stop now. We're good, right? And this is good because now that I stopped, I can still use my ship's movement to kind of, change my angle and move around my ship wherever I want, right? Okay, so guys, you have all the tools you need now, right, to do this. But I'm going to do one better, okay? I need to calculate the angle, right, to help you out. How do I find the angle that where I'm looking at? I want to pump up that angle, right? So I go on my ship. Here's my ship. First of all, let's get rid of the little C out in my move because that's driving me crazy. So let's get rid of this. Okay, so my move is gone. But I want to get the angle that I'm at when I'm turning. So when I turn, when I turn left, turn right, and let's just jump to that. So turn left. When I turn left to turn right, I want to calculate my new angle. What is my angle of attack kind of stuff? What is my current heading when I do this? So I can print it out. I can say that standard C out. So current heading. And I want to say that M underscore current heading. Right, there it is. Okay. Let's take this one. Whenever I move, I want to see what my current heading is, and it should be in degrees, right? So let's try this out. So whenever I move, whenever I rotate, so if I rotate left, you can see that that is negative 90. I can rotate to the right. That's positive 90, all right? So here's negative 90, right? I started here at 0. And you can see whatever each step, each time I press the button, I rotate 5 degrees one way or the other way. Okay? Make sense? Great. How about the direction? How about calculating the direction to my target? What's the direction to my target? Do I have that information? Well, actually, I had it, and then I lost it. Let me show you where that is. So that's in the seek function. In the seek function, what I'm doing is this. I say, okay, seek. My steering velocity, I call it steering velocity, is get my target position minus my position. Well, that's really the direction. And this one here, steering velocity here, I normalize my steering velocity to get my target direction, right? That's what my target direction is. We can keep this the same, this local variable, but this should be something that I update, right, and that I keep track of. So back to ship.h. I want to call this target direction. So this is like, we'll call this target info. And we'll say that it's a GLM vec2 object that is m_target direction. The direction of the current direction of my target. Okay, that's what that is. What is the current direction of my target? Okay? And I want to calculate this, right? I want to hold it in there when I do seeking. Okay, so by default, again, I'm going to go back to my ship.cpp. And instead of this being steering velocity, let's just call this target direction, m_target direction. Oops. Direction, right? So target direction is equal to this. I take my steering velocity, I normalize my steering velocity, and I get my target direction. Okay? And then my target direction, I'm going to pump into my velocity. My velocity is going to come from my target direction. Okay, but now when I do seek, guess what? I automatically have target direction, so I know where my target is. I want to kind of do this again, right? I want to do this get target direction stuff. This little line here is like get target direction. I want to be able to do this. Okay? That's what I want to do, this. And even though I'm seeking, I may have a call for getting target direction. Let's do that. So let's add a new function. So it's going to be a local function. And I'm going to call it get target direction. m_get target direction. I did this differently last time, but that's okay. And what this is going to do is going to do exactly what that other function does. Right? And exactly what this thing does. Go to definition. So instead of doing this here, I'm actually going to break this out. I'm going to take this part. I'm going to put it over here. Get target direction. Actually, do I really want to return target direction? No, I want to make this void. Hold on a sec. Undo. I want to make this void. So this should be not GLM vec2, it should be just void. So, or maybe instead of get target direction, let's rename this thing. Rename to calculate m_calculate target direction. Actually, the correct word is not even calculate, it's compute. Sorry, guys. So compute target direction, that's what that's going to be called, compute target direction. And then I'm going to get rid of the other one. Oops. There. This one is no good. So compute target direction. Did I do something wrong? Vec2. Oh yeah. It should be void. Sorry. What a mess up there. There. Compute target direction, it returns void. Why is that giving me, oh, this, because of this. I'm not going to return anything anymore, but I am going to do all this in here, and then I'm going to call m underscore compute direction, this one. I'm going to call that here, all right? So this way I can do this as many times as I want. Now, why is it giving me, why oh why am I getting errors? Oh. It didn't do the rename. Haha. M underscore compute target direction. Sure. And now that should be okay. Yeah. Okay, so compute target direction calculates what the target direction is. And once I've calculated it, it does it here in Seek. But I also want to do this compute target direction every time I move. I should know what the target direction is, right? I should be able to get compute target direction stuff. So, or I should be able to get it in some other way. How about that? So, when I turn left and right, turn left and right basically does this, but I want to be able to, just for now, I want to compute target direction when I turn left and right, or when I move, right? I want to be able to compute that over and over again. And this way, when I move, it's going to calculate where the target is. And I want to print that out too at the same time. So let's go to compute target direction here. So compute target direction, just for now. It's just a way I'm doing things, okay? So I got my target direction, here's my compute, and then what I want to do is I want to print it out. So target direction. Okay, so I'm printing it out. Why is this causing me a problem? See out. I don't know why. That should totally work. And maybe it's Visual Studio being quirky. Are we good so far? Oh, it does give me an error. What the hell? No binary operator. Why? What the? Why? See out. What am I doing wrong? Okay, target direction. Yeah, that's okay. Oh. Oh, it's a vector. Yeah. So I want the angle. That's what I want. My target area, not the. I don't want it to be a. So this is the target direction, but that's a vector. That's the problem. Sorry. So there's target position and target direction as a vector, right? Okay. Sorry. So what I want to do here before I do this to calculate the output is let's use a target angle. So we'll say float target angle. So our angle to target. Angle to target. How about that? That's going to be, we're going to use dot product. So dot product. And we're going to get the dot product, first of all, of wherever I am, the ship is, and compare that to the target. So get direction, get current direction. And then I also want to get the target direction. I'm monitoring target direction. All right, so that's what that's going to do. It's going to give me two vectors. The dot product is not enough. Remember, when I want to get the angle to the target, I need to take the arc cos of this thing. Arc cos of this. This is going to return a float, and I'm going to have to multiply this floating point number by util degtorad, right? So this thing here is now radians, right? And I want to take this thing and get the arc cos. So a cos arc cos. Or is it arc cos? What's my notes? Is it arc cos or arctan? I think it's arc cos. Sorry? What was that? I think it's arc cos. Yeah, I think it's arc cos. So arc cos of this, which is the angle to the target, and then I can just print that out. Let's see. I don't know if that's accurate, but let's see. That should give me the difference between one thing and the other. Let's see if I get that. By the way, this is the long way of doing it. So again, if I turn, but if I move, then I can see the current heading, right? That's what it does. But if I seek, if I press 1, you see the angle to the target is like 1.5 degree. That doesn't make any sense. Yeah, that's radians. And what I want to do is I want to convert that floating point number after I get it back. I want to get it back to, so I take arc cos floating point number, put it into this, and then I convert it back to rad to deg, multiplied by util rad to deg, which converts it back to instead from radians to degrees. Let's see if that even makes any sense. And if not, I have another thing to do that. Yeah. Okay, that's interesting. That's not what I expected, but it's fine. So 88. No, that definitely doesn't make any sense. So there is another function that I have that you can use that does all this work for us, which is called angle. So if I go util and I go angle and it goes from to, I can put in the from to from my ship. So get the current direction, current facing, get current direction. That's my current angle, and then m underscore target direction, whatever the target direction is. I can take that and get an angle back, and let's see how that works. So yeah, that makes more sense. 146. See that? So 146 degrees. If this is 0 on this way, it would spin this way 146 degrees to get down here. That's the angle to the target. And that makes sense, right? So now I want to do this compute target direction every time I turn. So let's do that during turns. Turn left and turn right. Okay, so I'll compute m underscore compute target direction. I'll do that each way, just to help you. And you don't need all this. I'm just showing you what it can do when I compute the target direction. When I do this and I turn, right? So I turn, you can see that the target direction is compared to where I'm at. So I'm facing negative 85, but here you can see that the target direction is 48 degrees, right? Is where I have to go. 48 degrees. That's the difference. And if I keep turning, the target direction should end up being something like 0. This is the, it's right in front of me. So what I need to do is, how about if I go the other way? How about if I go this way? So go this way, and you can see now that we're going to get the same thing, right? So if I'm facing this way, or if I'm facing this way, this one is 156 degrees, and this one is 143 degrees, right? I want to turn one way or the other based on the target direction. I got to turn 148 degrees at the minimum when I'm facing in this direction. How do I know whether to turn left or whether to turn right? How do I know that? That's the challenge. What does that 148 degrees mean, right? Well, look at my facing. My facing says I'm facing 5 degrees. All right, so right now I'm facing 0 degrees. This is negative 5 degrees, right? So negative 5 means if I'm facing, if my current facing is negative, right? That means I need to turn left, right? However, if I did that, that's not always true. Here my facing is negative, but here my facing is positive, right? So here, if my facing is positive and it's 173 degrees, right? What about when it's this, 180 degrees? Which way do I turn? Any way, right? It doesn't matter which way I turn. But here, I want to turn the shortest way. Is this way shorter, or is this way shorter? So I'm here like this. So I turn. If I'm turned this way, right? then really I should turn left, right? And here I'm at 0. If I'm at 0, which way do I turn? That's 143 degrees. How do I know that? It's because I take 180 minus 143, right? And I get some value. But how about the other? How do I know which way? How do I know which way to turn left or right? That's the thing. How do I know if I'm going to turn left or right? I know the angle between me now and my target. I know it's 120, this range of degrees. But the problem that I have, guys, here's my problem. Depending on whether I turn right or left, once I pass this area, if I keep turning to a certain point, once I go beyond 180 degrees, right, my current heading, as an example, if I go my current heading, if it goes down beyond the point where it's behind me, beyond the point where the target's 180 degrees, they mean something, right? But you can see as I keep turning, it becomes less meaningful, right? Because as I go here, then my current heading is 220 degrees. What does that mean, 220 degrees? I turned all the way to the right. And if I keep turning to the right, it's going to keep going up higher and higher and higher and higher. It's going to actually go beyond 360 degrees. Because I'm turning. Look, I can keep going, and it's going to keep turning 180. Keep going, keep going, keep going, keep going, right? So that's something I have to fix. When my current heading goes beyond whatever it's supposed to be, when it goes beyond 360, it becomes 0. When it goes below 360, then I have to take the angle of whatever it's going to be. So when I turn, if I go here, this is 0, right? This is 0. And let me just rejig this whole thing. I don't know if you know what I'm saying here, but let's look at this. So here, okay, so my angle right now, my current angle is 0, and my target direction is 143 degrees. So I'm 0 degrees. So 0 is, this is my facing. This is my 0 point, right? My target facing is 143 degrees somewhere. It's behind me, right? We know, we can see it's on the left. But the target doesn't know it's on the left. The AI doesn't know it's on the left. We have no idea where it is, right? And we just know it's this value, 143 degrees, okay? Okay, so if I turn left, should I allow negative degrees? If I allow negative degrees, right, then it's the difference between my current facing and this. So this should be, I should keep going until this is the same angle from a negative value as what I had before. Well, the problem is, if I keep turning, it's going to go beyond minus 360. So my thing to you guys, my question for you guys is, should we wrap around? We have this wrap. Remember the thing that we talked about on the lecture today? When we go beyond 360, we have a wrapping problem. How do we handle the wrapping problem when we turn? Right? When we're turning, how do I turn my ship so that when it goes beyond 360, it goes back to 0? Right? I got to make an if statement to do that. So, and this is the last thing we'll do today, guys. So if I go to my calculate, or we want to get current direction, this might get current direction for my ship, right? We set current direction and we calculate the turning. This is my computing my target direction, but I also have this idea of change. I'm going to change my direction. So I change my direction and I calculate my new current direction. However, if my current direction, m underscore current direction, right, is less than 0, 0 is okay, but if it's less than 0, then what do we have to do? What happens when the direction is less than 0? And by the way, it's not this, it's the current heading, right? So it's not, it probably shouldn't be done here. It should be done inside of the turns, right? So each turn will do something else. So when I'm turning left, so let's go to turn left for a second. So again, I want to go to turn left. So when I'm turning left, right, I calculate the new heading. But if my new heading, when I'm turning left, if m underscore current heading, right, current heading. Oh, wow. if it's less than 0, which it would be starting off, right? Then what number do I make it? How do I calculate the next number if it's less than 0? Do I set it to 0? No. So I'm turning left. I'm at 0, and I turn left. So if it's less than 0, then what happens? Do I subtract? Do I add 360 degrees? So I take the current heading and then make the current heading equal to whatever it is plus 360 degrees. Okay. Right? So that'll be like minus. So that'll be like. So that'll be like this. This will be, instead of minus plus, instead of minus, it'll be like I'll take minus 5, and then I add 360 degrees. So it'll be like 355 degrees this way. Right? And then if I go this way, listen guys, if I go this way to the right, if it's greater than 360, I make it 0. Right? I have to go, as I go greater than 360 degrees, I'm going to subtract 360 degrees. Right? Okay. Watch what happens now when I do that. So if I say M current heading, if it's less than 0, then M underscore current heading minus equals to 360 degrees. Okay? So that's interesting, but we're going to have a problem with this. I'm just pointing it out. And the same thing goes when I turn right. When I turn right, and if M underscore current heading, here's my wrapping problem, right? If that's greater than 360 degrees, anything greater than 360 degrees, and it will be greater than, I'm going to say that M underscore current heading is minus equal to 360 degrees. So what does this mean? So if I go to like 365, it's actually not 365, it's like 5 degrees. Okay? But, guys, what does this do from my game perspective? What does it do? So, okay, so here I am. Let's take a look at the angles over here. I turn left. I'm at minus 365. Oh my God. Oh, what have I done? It's a minus something. And if I go right, then it's not really making up for that problem. Okay, let's try it the other way around. So if I go to the right, if I go to the right, I keep going, yes. But as soon as I go beyond 360 degrees, then I'm okay. This wraps nicely on the right. It keeps wrapping, and it's not so bad. It keeps on wrapping, and I'm okay, right? But what happened when I went to the left? When I went to the left, and I get these crazy values. What happened? So what did I do wrong? Well, turn left should be plus. So again, turn left, minus 355. So now you can see that if I keep turning left and I turn to face the target, my ship is going to be at 215 degrees, right? But my target is going to be like 1 or 0. I'm pointing at the target now, right? But my current facing is 215 degrees. Why? Because I'm going left, right? I'm turning to the left. And I start at 360 and I go down, right? And this is where we get our turning problem. Okay, I'm just going to point this out. So if I'm facing this way, and this is 0, right? And it says I have to go to 143. 0 is like, it could be 0 or 360. So what's closer? Is 143 degrees turning this way? Is that closer? If I turn to 143 degrees, right? I mean, I'm at 0. And the difference between where I'm looking at and where I'm should be at is 143 degrees. But what does this 143 degrees mean, right? Here in this context. Here's something else. If I move my ship, right, to up here like this, right, and then I calculate where I am. Okay, so here's my current angle, right, and my current heading is 0. And my target direction is 174. But this 174 is, Well, that assumes that it's this way, right? So if I turn to 174, and on this particular part, if I go to 174, let's say, it's pretty good. I'm okay at this point, right? So in this quadrant, I'm good. I'll leave you with this thought, okay? What about over here? So let's go down here. And does this work if I go down here, right? So I'm here and there. Okay, so it says that my current heading is 5, but my target direction is 156. What? What the heck? I mean, it's right in front of me. What do you mean 156? It's 0. What does this mean? Right, so this is where I am. Look, and my current target is 152. Current target direction, 152. What the hell? That's a problem. So here's this one. So if I do this, behind me, current heading is 210, right? And my current direction is 57. My current direction, right? The difference is really what that is. The difference is 27 degrees. That's wrong too. That should be 0 right here. Look. Current heading is 180. My target direction should be 0. And if I turn the other way, okay? So something is messed up, right? I'm just being honest with you. So how about this situation? So here, my target location is 117. Okay, so this should be like a 180 degree difference, right? My current direction heading is 270. Does that make sense? Because if this is 0 and this is minus, this is 270, but my heading is 62. How does that make any sense? What do these numbers mean, is what I'm saying. And this is a hint of how you can figure this out. Anyone have a clue of what they would do? Guys? Anybody have a clue? So the wrapping problem was fixed, but we caused other problems, is what I'm saying, right? So one thing to do is we can also match the coordinate space of my object. Let me just rejig this for a second and show you what I'm talking about. So right now, if this is 0, my space is 143 degrees. What it's saying is, if you take this, the difference in angle between this angle and this angle is 143 degrees on the left, right? That's what this means. If I move this back down to here, right, and if I move this around, my target direction is 148 degrees. Is that right? Something's not right. Which means we're not passing in the direction again somewhere. We need to pass it in again. Like we only passed it in once. Look, this is a bug, guys. So watch, let me do this one more time for you guys to see this problem. Then we'll stop for the day. Watch. So my target direction is 143 degrees, right? I'm not moving my guy. Now I'm going to move my target down here. Here's my target. Yay! And then my target direction is still 143 degrees. That's a problem. So when I move my ship, when I move my target direction also has to be updated. So that means that in my my game.cpp, my location is not being updated. So whenever I move my target, which is all these things, it sets the velocity, right? WASD. But one thing it doesn't do is it doesn't set the target, right? So my target's location is not being sent to the ship. Let's send that whenever I move my target. So I'm going to say that whenever I move m_p ship, and then I'll say that set target position is equal to m_p target dot get position. And this should be more accurate because we never did this. We're not doing it when we move our ship. We're only doing it when we do a couple things. We need to accommodate for this every time the target is moved. And this, if we did this here, well then that, again, this predisposes us to think there might be a better way of doing it. Okay, let's try this again. So again, if I try this out, you can see that if I move right and left, 143. But if I move my ship around, and if I move around, you can see that the difference is the target direction is 175. That's pretty good, right? Now it should be around 180, look. Right, so, yeah, that's pretty good. So now if I go in front of me, what about this? It should be 0, right? So it should be in front of me now. Now we're better, right? So I move my target, my ship is 0, I don't have to go towards it, right? Where my problem is what about if it's here, right? What is my ship? It's 80 degrees approximately. And, right? Target direction is about right? I want to move this to where it is. So current direction is 90, current heading is 90. I'm moving towards where it was, right? My target direction is 8. Okay? So it's like right in front of me pretty much, 0, right? I can go within, something like, I can move down to where it's supposed to be. I can take my 90 and subtract 8, and I can get close to where I'm supposed to be. It's going to probably do something like this as I'm moving, right? If I go behind me, I'm back to 180. If I go over here, right? 96 degrees. So I need to move this way, right? And it's a move. I'm turning. I'm adding to my current location. My problem is I keep calculating every time I move. I'm also calculating the new angle, right? What was the desired angle? What is the new angle as I'm moving? I've got less and less degrees to go, is what this means. Okay? My problem is, if I'm like this, which way do I turn? So I'm 275 degrees on my left. Do I turn left? Is that the best way to turn? Or do I turn right? What's closer? What do the numbers tell us, right? If I got it, my target direction is 83 degrees and I'm at 270, right? Do I subtract 270 minus 80? Right? Is that what I do? And does that determine how I move? Or something else? How do I find out that it's this way? The other thing is, what about if my target is on this side, right? So now my target says it's 86 degrees again. Look, it's the same thing, right? It's 86 degrees this way and same that way. This way or that way. How do I know if it's on my left or right? That's my challenge. How do I know? They're both the same. Left or right, remember? What happens is with dot product, it doesn't matter. On the right, it's on the right side, positive. On the left side, also positive. Because the hemisphere cuts in half. When I'm looking up, dot product basically says this right hemisphere from 0 to this part right here, from 0 to the right, that is, 90 degrees or 180 degrees. And from 0 to the left, that's 180 degrees too. So when I'm calculating my position of my object, if I'm on the right or the left, I can't tell. I know I'm 90 degrees, but I don't know which side. It's on the right side or the left side. Not the way I've done it right now. All I know is it's positive. Okay? That's the difference in the actual absolute value of the difference in angle. I don't know if I'm going to turn left or right. So that's your challenge. How do you figure out, and there's some stuff you can look up online. This is why it's a challenge, right? There's some stuff you can look up online, turn right or to turn left, right, when you're moving. Okay, and I want you guys to do a little bit of research. This thing is going to be due next Friday, right? It's going to be 1% of your final grade, right? So it's not going to be a big mark. You have a lot of it done already for you, all right? And that's how we're going to end it. Okay, so we're going to stop recording now. Any questions before we go? Because we're running overtime and Professor Josh is coming in. Okay, guys, see you next week. We'll see you Thursday. Good luck with your lab. I'll post it later on today. Thank you.
Now, I know you guys' brains are melting right now, so
They're melting.
Start off with a 30-minute break. How's that sound?